at least, welcome. So at least the HDMI works, the demo doesn't, little hint. So today we're going to talk about GitOps. And I wanted to show you amazing things, and I'll show you some cool stuff. Unfortunately, it's not fully working, but of course, like I wasted 5 minutes fixing the HDMI. That would be exactly the time I could use to fix the policy, which I'll explain in a moment. So, long story short, I just arrived, so I'm also quite late. But I'm going to talk about ClusterAPI, GitOps, ArgoCD, all sorts of cool hype words. And I hope you leave with some more information and some excitement and maybe the willingness to try new stuff, which is what I do all the time. And I'm actually having pretty much fun with it. So yes, this is ephemeral clusters. Ephemeral means like transient, like things that are here in a moment and go away the next. They come and go. They are not to be too much attached to, right? So pretty much we used to have the analogy kettles and pets. At some point, this was a very famous concept in DevOps, right? So we moved from treating virtual machines or workloads as pets, where we give them names and we care for them, to kettles, assuming the fact that kettles are disposable. But of course, we all know cows are really nice animals. We don't want to, at least we don't want to say it out loud. So at some point, there was in the DevOps movement, there was this idea of being more politically correct. So also the idea of pets versus kettles went away a bit, or at least was rephrased into, well, sometimes like, as I will show you, like minions and controllers. Even the same, you know, Kubernetes, right? So, I mean, I have the t-shirts, right? So in Kubernetes, in the very beginning, there was, the nomenclature was to call the control plane, the master node, and the worker, this is just a parenthesis to introduce the idea of ephemeral clusters, to call the control plane the master node, and the worker nodes were called the slaves. And then, of course, like hit some buttons in some people, rightly so. So the whole community, the whole Kubernetes community adapted to new ways of naming things, and if you know now, we call them control plane and worker nodes. But before, in the very beginning, it was like a master and slaves, not a great name. And so clusters are also not to be too much attached to nowadays, right? So you may have one big cluster that does everything, but more likely, I think I lost it. More likely, you probably have several clusters, right? So, or clusters that are working for a specific function, specific workload that only exists for a limited amount of time and then goes away. And what do you do with that cluster, right? So how do you monitor it? How do you create it? How do you manage the life cycle of this ephemeral cluster? And this talk is all about that. I call it also the cluster vending machine, as in, you know, like want a cola, you ask for, you go to the machine, you press some buttons, and you get a bottle, and that's the same thing with clusters. So at least I'll show you that you can do it with open source tools, all tools that exist within the ecosystem of Cloud Native, the Cloud Native Computing Foundation, and all very, very popular now, and that can be put together to give this idea of cluster vending machine, or at least the impression of having something on demand whenever you like. Also, maybe you can find other talks from KubeCon, this idea of having a cluster per PR. Imagine you want to test new software, and you want to, instead of testing inside a cluster or within the same cluster, you want to test it in a completely separate infrastructure. So, and for that, you open a pull request, and you want that pull request to be tested in isolation, in its own cluster. How you do that? Well, with this tooling that I'm going to show you, it's possible to have a new cluster for every PR, do all your testing, wait in there until humans go and validate, and then destroy at the end of the PR. When the PR gets merged, for example, if it's abandoned, that cluster can go away. So these are all ephemeral clusters. They fall under the category of ephemeral infrastructure. And infrastructure is code, of course, because all these clusters are defined in code, and I'll show you in a moment. So I'm too long on the first slide, but just because they are, just to introduce the ideas here. So this talk comes, of course, from me and my esteemed colleague, former colleague at Microsoft. I also don't work as solo anymore, so I'm an independent guy now. So for a while, I just don't advertise it too much, but I am actually, I used to be at Microsoft where I worked with Joaquin, then I moved to solo. By the way, I'm also one of the, let's say, I don't know, maybe we are 4 or 5 CNCF ambassadors. So I'm an ambassador for all things cloud native in the Netherlands, of course, and abroad, because we run the Dutch Kubernetes meetup. It's a pretty large meetup, so if you want to know more, or you want to talk about cloud native technology, that's the place to be. So meetup.com or community.cncf.io, search for Amsterdam. We call it Amsterdam because we need to find a city to be connected to, but we organize meetups all across the Netherlands. By the way, in June, 13th of June, we didn't announce it yet, but probably today, the first week of June, actually, is the official birthday of Kubernetes. How old is Kubernetes? Who knows how old is Kubernetes? 10 years old. So my son is 12, so it's almost like my son. So Kubernetes starts 10. 10 years from the very first commit on GitHub, made by Joe Beda, I think. It's, if you look at Kubernetes, if you go to github.com, search for Kubernetes repository, go all the way back to 2014, you will see the first commit. So Kubernetes started 10 years living the life, of course, like it went from a baby until the teenager, almost the teenager that is now, and is becoming quickly the, I mean, it is the de facto application platform for everything. So that's why years ago we started the meetup to get the community together, and that's a good place to be. If you want to know more about that, please reach out to me. So why we are here, right? So we come all the way to ephemeral clusters, but where do we come from, right? So first it was like punch cards, and then it was, oh, let me SSH into this server so I can install, I can run apt-get or whatever, or change the configuration, and that works. Doesn't mean that it's the right thing to do today. I mean, it was the right thing to do when we didn't have all the configuration as code tools, Puppet, Chef, whatever. I was there when, I mean, I remember the Puppet configurations, all the Ansible, Salt. Do you remember this tool called Salt? It was pretty awesome, actually. It was good then, doesn't mean that it's good now. So we went from pets, where you have to get into the machine via SSH, so you have to distribute your keys and so on, into a new world where application change form, change shape. They went from install this package, unpack this tar.gz into a virtual machine or a server and run it, or Java, jar, whatever. That thing became a container, right? So that application is the same application, really, still Java, maybe now it's Rust or Go or WASM or something, but it's still the same code. Let's say it's Java or whatever. It just is packaged in a different way, and it's packaged in containers. And so no need for SSH anymore. Still do it, still there. I use it, of course, every day. But what is the tool that at some point we all started using was Docker. And of course, Docker works on one machine and is great, but when you want to scale it, then you go to Kubernetes. So we went, the application landscape, the way the application look change. The same application, same code, just in a different package, a container. And then, not too long ago, let's say 4 or 5 years ago, not right away from the advent of containers and Kubernetes and so on, but a bit later than that, we were still doing a lot of imperative CI/CD pipelines, right? So I don't know if you remember, but we had clusters, and then there was like Jenkins pipelines, and maybe if you were fancy, you were using GitHub Actions or Azure DevOps pipeline, still imperative, like a kubectl apply this, no question asked, you know, which means that Azure DevOps Jenkins must have the kubeconfig for the cluster somewhere, because they need to access it, because people are lazy, I'm lazy. We were just giving cluster admin to Jenkins because we don't bother really restricting the tools to exactly what they need. So there were plenty of cluster admin credentials spread over some random Jenkins server or some GitHub or GitLab account. That's not great. And so the new kid on the block, been around for a while now, called GitOps, right? So change of mentality. We don't push things, we pull them out of a Git repository. I don't know if you know GitOps, if you don't, it's really like the de facto way to deploy application in cloud native, not only Kubernetes, by the way, so there's also a way to do this with full infrastructure, right? So instead of pushing Terraform code or Terraform apply an entire AWS or Azure account, you can let a GitOps controller pull in those changes, pulling that infrastructure as code, and apply to your Azure account or AWS account. And then, of course, like what's next? Of course, we don't even need to do any of this because we just ask ChatGPT, and they will tell us what to do, and maybe tell us what to watch and what to read, and which conference to go, and so on. But that's the next thing. But by the way, also, it's strange because I saw the program of this, and there's a lot of AI. I'm also a big fan of AI, of course, because cloud native and AI, small parentheses, are feeding into each other. Just so you know, I was here. Actually, I was in this really venue last week for AI Community Day. I was giving a talk about cloud native and AI. So this is the future present, is the future that is happening right now. Before our eyes, all this cloud native thing that's been around for a decade, really, Kubernetes, triggered the innovation in AI. Of course, like the big innovation is the advent of transformers and RAG and so on. But where do you run all this stuff? In Kubernetes. OpenAI famously runs the largest cluster that I know of, at least it's 7,500 nodes to train ChatGPT. And AI is helping operators like me and you to run leaner and possibly greener infrastructure on cloud native. So just so you know, there's all, and these are the topics we talk about at the Kubernetes meetup. Probably at the 10th birthday, we're going to have a few talks about how AI feeds into cloud native and how cloud native helps AI to deliver. Small parentheses, so back to GitOps. So what is GitOps is this new idea of pulling instead of pushing. So it's even better, more declarative way, hands-off way to deploy applications. So I don't need to even see the cluster. I don't need to have any idea about the credential for the cluster. The cluster is aware that is my code in Git or in the version control, and the cluster will apply all the changes that I pushed into the version control. So there's still a push, but I push to Git and not to the cluster. So that's because developers, operators, they are very used to push, right? So, and that's what we're going to do today. We're going to push changes, and some clusters going to appear out of nowhere. So it's declarative, Git-centric approach, so the core becomes the center piece of everything. The single source of truth is Git. Could be subversion, I guess. Nobody does that anymore. Good old days or bad old days of subversion. But that's now the where everybody, all the developers, operators, can reason about what's going on. So which version is running in the cluster? Well, just check Git. Just check the Git history, and I can tell you right away, without even going to the cluster with kubectl or whatever, I can tell you right away which version is running, which code is running, because I have access to Git. There is also, of course, GitOps is part of CNCF. There's a working group that takes care of defining what is GitOps, defining all the best practices around GitOps. So you can actually contribute to this, right? So if you have an opinion and you gather enough interest and you can convince other people to change the definition, of course, you're very welcome to collaborate on that. So there are open meetings, there's a working group within the CNCF. So it's not, so you know, there's like the Kubernetes community. It's a big one, of course. Everybody is like all sort of working groups within the SIG, we call it the special interest group within Kubernetes. But if you zoom out, you see the Cloud Native Computing Foundation, of which Kubernetes is one of the 184 projects. So you can be in the Kubernetes community and be oblivious to the CNCF community, or you step out and there is the whole CNCF community, which includes, for example, the Open GitOps working group. Personally, I'm in the TAG, Technical Advisory Group for Environmental Sustainability, another parenthesis, of course. So we are very concerned with the only planet we have, this one. So we also want to show that the community, this Cloud Native Computing Foundation, which manage, by the way, 184 projects, everything from Argo to Flux to FluentD or 184. I'm not going to tell you every one of them. But so within these projects, we should, the working group I'm part of and I'm actively involved in, wants to raise awareness on consumption, or like how building and using this software has an impact on the planet. So the carbon emission, carbon intensity of software, and so on. By the way, we're also going to have in October Environmental Sustainability Week within the meetup. So it's like a whole day dedicated to this topic. So I'll come back to that later. And so what are the challenges of GitOps? So it's not clearly, it solves some problems and then creates more. So as long as you create less problems than you solve, you should be good to go. So definitely you solve the problem of security and automation. So it's more works better, as in less prone to errors. So GitOps, the main advantage is I'm making less mistakes because my changes are being reviewed by another human or automatically tested. So I'm not doing anything stupid. And it solves, and of course, like it solves problems around scaling because I'm pushing one time and all sorts of clusters can now get the changes. But of course, it's more problems. There are some problems still up there that we're going to figure out together. So for example, observability of these ephemeral clusters. If a cluster lives only a couple hours, you know, if a tree falls in the forest, but nobody can hear it, did it really happen? So how can you capture those signals from an ephemeral cluster before it goes away? And where are they stored? And of course, scaling, it's a problem, as in I want to run more stuff, more clusters, more applications, more users. how do I solve the operational problem of making these people work together? So, ephemeral clusters, what we're going to show today is this idea of a management cluster, which is also the observability cluster. We can also split it, of course, so that's GRU, we call it GRU, and then the minions are the workload clusters. Now, there is a way to define clusters programmatically within Kubernetes itself, with Kubernetes native object, we call it. So a Kubernetes object is things like pods, services, endpoints, or deployments. Those are Kubernetes objects. Kubernetes, it's amazing because as this little guy, CRD, or GER, or whatever, that is really the core of what makes Kubernetes awesome, is the extensibility of the platform. So if an object doesn't exist, you may invent it, right? So, and the ClusterAPI, CAPI stands for ClusterAPI, and CapZ stands for ClusterAPI for Azure, which is just what we, instead of, it's a long name, ClusterAPI for Azure, so we just call it CAPS, and that's done. So if you notice, when you install a cluster, when you get a cluster out of the box, like a kind or a AKS cluster, you can list nodes, but you cannot list clusters because there is no idea of a cluster in native Kubernetes, out of the box. So the community came together and said, well, what if we want to manage clusters within Kubernetes itself, right? So go beyond Kubernetes to manage other clusters. And that's the idea behind ClusterAPI, an API that defines clusters within Kubernetes as objects. Because they are Kubernetes objects, you can deploy them with GitOps, or you can inspect them. They have like a very clear API, so there is a definition of those objects. Because they are Kubernetes objects, they follow the rules of role-based access control. You can allow some people, some groups, service account, whatever, to create those, and some other people not, because you want maybe developers to not be able to create cluster, because that could cost you money, right? So, but maybe you want other developers instead to create, and I will show you in a bit, maybe you want some developers to create clusters in AWS, but not in Azure, or virtual clusters instead of full-on clusters, and I'll come to that in a bit. So, simple, you get a Kubernetes cluster, that's the management cluster, you create a bunch of CRDs, doesn't matter how, you can do Helm, you can do kubectl, create, cluster, whatever, but what matters is that once you create this object, there is a controller. This is the operator pattern in Kubernetes, very famous also, big innovation, or at least something that distinguishes Kubernetes from every other container orchestration platform, something that is very unique to Kubernetes, kind of the thing that really took people by surprise, because now you can watch for these objects to be created. For example, a cluster, there's a controller, this is the controller operator pattern. So a controller sits there, watch for new objects, and then does something about it. So the logic to create Azure, AWS, Google Cloud clusters sits inside the controller. If it's the CAPS, ClusterAPI for Azure, there's a logic to create clusters in Azure. If it's the, I don't know, I call it CAP AWS, there's the logic to create EKS clusters in there. Same with OpenStack. There's a very rich ecosystem of providers for ClusterAPI. You can think of anything. I was looking for things like VMware, of course, but also Proxmox. Anybody use or knows what yeah, so there's actually one for Proxmox. It's not great, but it kind of works. And you can create, and there's one, of course, for vClusters, which I'm going to introduce in a moment. vCluster is these other projects. So these are infrastructure providers. OpenStack, Azure, You pay money, they give you infrastructure, right? So a cluster in Azure, an AKS cluster, is just a bunch of virtual machines in the end. It's nothing. What makes them a cluster is because Azure installs some magic in it, well, basically the Kubernetes components, so they know each other and they form a cluster. But they are infrastructure. Infrastructure as a service, yes. vCluster is slightly different because it's a tool to deploy clusters, fully formed Kubernetes clusters within a larger cluster. And they are virtual because, of course, they are not real infrastructure. They are just virtualized components of Kubernetes running in pods inside a bigger cluster, right? So there is the CAPS controller for Azure. There is the ClusterAPI provider for vCluster, which we're going to use as well in the not working demo, but I'll fix it soon enough. So this is how we work. So how we control all this, instead of going in and creating an object by hand, well, I'm going to have a manager cluster, right? So a cluster that contains all the components to create other clusters. It means also in this cluster, I have the credentials to Azure, AWS, whatever. So it's a bit of a special cluster because it contains the state of the workload cluster. So these are workload clusters, call it minion, that will run the actual application, right? So in the manager cluster, only components, like infrastructure components, we call it, or whatever you want to call it, things like Grafana, Ingress, Thanos, which is a Prometheus-compatible tool that accepts metrics, and of course, the provider, and ArgoCD, which is our GitOps controller for today. There are other controllers like Flux. Just because Argo has a fancy UI, people tend to like it more. But there's another project called Flux, which I used to use it a lot. Then I forgot about it, and then I'm actually going back to Flux a bit because it's cool. And Joaquin, my co-speaker, which is not here, of course, has a crazy project he's working on. He did a slightly different version of this, and the project is called Flamingo. It's like Flux plus Argo, but for now, we also don't install a GitOps controller on the remote clusters, on the workload cluster, because we want to do everything from a central Argo. Oh, so doing well. Wasting time, which is great. So I don't need to show you the broken demo. No, I will. And I'll show you how to fix it, actually. So everything runs here. All the monitoring tool, I also sometimes call this the observability cluster, and these are the observ, the ones that's also the solution to observability. The cluster comes up, does nothing is stored locally. All the metrics are shipped immediately to Thanos on the observability cluster, store them locally or whatever. But even if the cluster only lives for 10 minutes, you're going to have 10 minutes worth of metrics with the tag, with the label, cluster worker cluster X, shipped to Grafana, and then you can see them even if it's only living for a little bit. Make sense? So to recap, we're going to use Azure because I used to work at Microsoft, so I had free clusters. I could just create clusters like there is no tomorrow. Today, I'm actually paying for it, so in a bit, I'm just going to destroy it. But also, yeah, it's convenient. But you can replace this with any other providers, also Minikube, kind, whatever. ArgoCD is the brain of all this. Without ArgoCD, we'll not be able to do stuff automatically. Of course, the trifecta of Kubernetes networking, you know where they are, Cert Manager, External DNS, and Ingress and Nginx. I might have used Istio. So this was a question at some point in sometime we did this at KubeCon last year, so that's why it's so popular. So how do you actually connect these clusters together? They are technically not connected, like they are disjointed. They don't see each other unless through, of course, internet, right? So of course through public internet. A way to connect them, and I might expand this, is to use a service mesh. Istio, Cilium cluster mesh, it's not part of this, but it's, so that's why I might change this Ingress and Nginx to a fully on service mesh. And anyway, observability trifecta, again, seems like number 3 is the magic number. And this is only for metrics, right? So we are not talking about logs. Easy to extend. Just add Loki to the mix and have the workload cluster shipping logs to Loki. Traces as well. But we want to keep it simple. Only metrics will do. Kyverno. Who knows what Kyverno is? Amazing tool. I call it the if this then that. You know this if this then that. Like it's an amazing web tool. For example, when I don't know, every morning sends me an email with the news, or whenever I add a song to Spotify, sends it to my son, or something like that. So it's a tool like it literally is if this, then do that. Kyverno is the same thing. Why we need Kyverno? Because ClusterAPI creates these clusters and then saves the kubeconfig, the credential to access the cluster, as secrets in its own namespace, in the namespace where this object defined. But ArgoCD can manage these clusters only if can get his hands on the kubeconfig. And so you need a translation between, and of course, like our luck, ArgoCD likes to have this secret in a very specific way, which is not the regular way. So you need a translation between these secrets and ArgoCD secrets. And Kyverno does exactly that. It detects when there is a new secret of certain name or some conditions are met, extract the data from the secret and put them in another secret in ArgoCD namespace, so ArgoCD can finally manage the cluster. And that's what is broken, by the way, so we'll fix it. Or at least I'll show you how it's supposed to work, but I know. It's, of course, ClusterAPI and vCluster. Now, no minions were art in the making of this demo, only infrastructure suffering. So, let's see. So all this stuff is in, and of course, I never close any tab on my machine. So I'll just open another one because it's, yes, but at least I have a thing that says prevents me from duplicate tabs. It's crazy, but I like it a lot. So this is the repository. IMS0 is my GitHub user. It's everything there, so it's simple enough to understand. So of course I took some steps already because you don't want to wait 4 or 5 minutes to create an AKS cluster. So also there's a magic with identity. Why do I need identity? For external DNS. Because I want everything to be automated. I create a cluster, bam, I'm going to I don't like to make demos with IP addresses. I like to have proper DNS names because that's how we work, right? So you don't go to enterprise or corporation and put an IP address in there. It doesn't work. So I like to do my demo like I'm working for a big company. So the first thing I do, so I'm here. I just create a cluster, right? And I got the credential. So you can tell this is an AKS cluster. like Microsoft made it, right? So just out of the presses, out of the machine. So that's a very simple Kubernetes cluster with 2 nodes, I suppose. 2 nodes and so on, right? So first thing we do, we install ArgoCD, and that should not take that much. So it's just a simple Helm. No, I have to go in. So you have to go into the repository, of course, because I have some values in there, of course. The values are very simple. So I like to keep everything under the GitOps folder. There are ways to do this, of course. So in every folder, there is a folder, in the management folder, management cluster folder, there is a folder with the app, in this case ArgoCD, and I have some values in there. Most notably, I'm using like a, and feel free to steal everything from here, but because I don't want to deal with authentication, I want to have ArgoCD read-only, so I just do this. And of course, there's Let's Encrypt tools. But of course, like this is just Argo, right? So, and you can tell Argo is running now. It's still not what I need, right? So what I need is to have the first objects that you need to deploy the rest. So I'm just installing Argo. Argo is not aware of any GitHub repository, is not doing it, just sitting there waiting for me to do stuff. And the stuff is, of course, using these ArgoCD initial objects, ArgoCD initial objects, which are just two objects. One is the project. In ArgoCD, you can segregate objects inside projects. Very, very cool, just do it. Because this, whenever you use ArgoCD, you get this default project. And everybody has all the rights on the default project. That's very bad, very wrong. It's always good practice in Argo to create a separate project for infrastructure, for application, and so on. And then within this project, infra, I'm telling ArgoCD, go to this repository, which is the repository I'm working on, go to this path, GitOps management, and just install everything you find there. But don't forget about values.yams and dashboard.yams. Don't install these files because, of course, they are not Kubernetes files. So it's very powerful. Argo is so powerful, actually, you can exclude files. So you can have a GitHub repository, but you can also put like a readme.md. But if you put it in the exclude, ArgoCD will not try to deploy it, of course, because also not a YAML. And lo and behold, and I'll put it a bit smaller, because then it fits. See, this is Argo doing its job. As I already passed it, but it installed Thanos, it installed Kyverno, it installed everything that is on, so Cert Manager, Grafana, in 5 minutes, yes, sure. Just in time to show you where it's broken. And of course, this is Prometheus doing its job. Not only that, of course, it is getting its ingresses. Cert Manager is doing its job of getting certificates. These are Let's Encrypt HTTP challenges being created. So these are pods that Cert Manager creates, so you can talk to Let's Encrypt and get the certificates. If you can tell, certificates. Some of them are already true, as in ready, so these are real certificates for my domain, right? So that's how it works. Now there should be, the last one should be true in a second, and then you can go to here. Bam. Few seconds. These are read-only ArgoCD, so I didn't log in. So I cannot change anything. If I try to sync, it will say, no, I'm not authorized, because I'm just a read-only overview of Argo. By the way, you can tell all the projects that been, all the applications that exist in, in GitOps management. So all this stuff is being deployed. Awesome. Now, the next thing you do, of course, now you have a working Argo cluster, it's working fine. You can also have a dashboard, with azure.dev. So Grafana, again, read-only. So just because I'm already loading, there's no data, but yeah, cluster management, I think last 5 minutes. Soon enough, you're gonna get some data in this one, but let's continue. So, and now you need to deploy the ClusterAPI. I should have done it with Argo, of course, with GitOps. Unfortunately, it's not mature enough to actually being deployed with ArgoCD. Unfortunately, so good old bash scripts, and then it just defines some secret here and there, and then it creates the so it gets the cluster. So it creates a secret with the subscription ID and so on, and creates a role, because the cluster needs to create other clusters in Azure. So you need a role, you need a service account. As that AD SP create for airbag creates a service account, creates a service principal that has the right to see a scope on the subscription is a contributor, which means that you can do pretty much everything, including creating other clusters. So, and that stored as a secret, and then also installs ClusterCTL init infrastructure vCluster, the ClusterAPI provider for vCluster, because the demo includes creating both AKS clusters and ClusterAPI. Now, what does not work, of course, this works, that's all right. And I'm gonna demonstrate with something simpler. So normally, at this point, I would open a pull request against this file over here, workloads, for example, vClusters. So see, this is a application, and there's, no, sorry, not this one, but the application sets for, no, sorry. Wait, no, it's in, of course, these are in the management because they are, come on, clusters, yes, yeah. So at this point of the demo, I would, remove these comments here, and just by open a pull request, it will tell Kubernetes, it will tell Argo to create a vCluster of this kind. Now, I'm not going to do it. I'm just going to do it because I'm at time, but this is done. You can tell all the pods here. There's also their new ClusterAPI stuff. So what I do here now is to go to charts, KPI vCluster, and I can do Helm template, for example. So I create this will be created automatically. Create NS VC2, Helm template. This can be done, of course, by a pull request. But what I want to show you here, of course, I create an object called cluster, which is provisioning, and an object called vCluster, which is also provisioning. And then eventually, you should be able to see if everything is correct. these are the logs. So it's actually the ClusterAPI controller for vCluster. It does for me an Helm upgrade, right? So a Helm install of this vCluster. And then eventually, yes, this is the control plane for the vCluster being created. So by just using Helm, could have done it via GitOps. Now, the only problem of this, of course, is once this is done, see, like, if this was AKS cluster, it would take minutes. But it's a vCluster, so it goes up in seconds. And this is what you want to use for example, pull request. And also creates core DNS. And now it's a vCluster completely isolated. Now, there is a secret created by this ClusterAPI controller. And the whole point of the automation of the demo, which doesn't work right now, is to create, is to have this Kyverno policy. See, there's one for AKS clusters, and there's one for vClusters. So this is the Kyverno, if this then that magic. It takes a secret of the name vcx kubeconfig, type secret in any namespace, of course, and then it extracts stuff from there and generates a new secret in the namespace ArgoCD. That doesn't work. I mean, it's just something stupid with the, so vCluster changed the structure of the secret, of course, and then everything falls apart. In fact, you can see yeah, so there was some error here, actually. Yeah, so there's supposed to be a new secret created here of the name, kind, secret, name, vCluster name, VC2, but it doesn't exist because Kyverno, what was it? Yeah, admission controller. Yeah, so there's some error in there. So it's just the policy that that doesn't love me today. But yeah, so that's and I saw the error somewhere. Yes, something like that. Anyway, so this is all the thing that kept me up last night, which I couldn't fix anyway. But anyway, so this is what we do. Yes, here. So we did the demo. Some tricks I used. So I didn't use the ClusterAPI operator to install ClusterAPI itself. Sorry. ArgoCD or read-only mode. It's handy to use. And I use projects for this. Also, things that we can improve here is now I'm creating the cluster by editing a file in the main repository, but you may want to give a repository to your developer so they edit that, and they don't need to have access to your main repository. And you do this just by, yeah, it's quite simple. So this is where you add, so you just put this somewhere else, and that works just fine. So that's, and they just have to uncomment or add stuff. They can call them anything they want and so on. So multi-cluster is not easy, but it's possible. Got the right tools at your disposal. You can split configuration and so on. What do we do here? Of course, like using Istio to connect everything together. That would be cool. Demo when I fix this Kyverno thing. That's where you find the repository with the code. If you have any, please open pull request issues and so on. But I'll be happy to be here and have a minute for questions, even if I'm totally out of the time. Yes, thank you. Any questions? Yes.
You said opening a PR it would trigger a change.
Yes. Yes. So, and it's not there yet because, of course. So the power of Argo lays into the generators. So these are application set. So ArgoCD also changed the way it works. So first, I still use like application. That's one application. And then you can have application set, which generates applications. How do they generate applications? If you look at this, actually, this is an application set with a list generator. Just take a list and makes X number of applications out of the list. The pull request generator generates applications out of a pull request set, you see? So if you use this, of course, you have to give the GitHub credential and so on. Whenever there is a new pull request, an application set is an application is created out of an application set. Application set is like a deployment. A deployment is a template for pods. Same thing. Application set creates applications out of a generator. In this case, can be pull request, and this is what we can do in the next demo. That will work for sure. But yeah, so you can do it out of GitHub or GitLab or whatever, right? So you have to say which repo and so on. More questions? Otherwise, I'll be happy to wrap it up. Cool.